Section 1. Earth's chorus. Start at home, because Earth is making noise right now. Not sound, very low-frequency radio waves, generated by lightning storms and by electrons spiraling through the Van Allen belts, the two donut-shaped radiation zones wrapped around the planet. Shift those waves into audio and you get something astronomers call chorus because it sounds almost exactly like birdsong at dawn. Ham radio operators have been catching it on backyard equipment for decades. NASA's Van Allen probes got the clean version, with instruments built specifically to listen. And here's the part that spoils the beauty of it. Researchers think these same waves can accelerate ordinary electrons in the belts up to relativistic speeds, turning them into what are literally nicknamed killer electrons, fast enough to punch through spacecraft shielding and fry the electronics inside. The birdsong is also a weather forecast for the thing that kills satellites. Section 2. Marsquake. Now go 70 million miles out. On April 6, 2019, NASA's InSight lander picked up a faint trembling in the ground beneath it. The first marsquake ever detected. This one isn't a conversion from radio waves. This is genuine ground motion, recorded by a seismometer sitting under a dome on the Martian surface, then sped up so human ears can register it. It's a whisper, a low rumble that would be almost inaudible if you were standing there. But every one of those tremors is a probe. Seismic waves change speed as they pass through different materials, so by timing them, scientists map the inside of another planet, the thickness of its crust, the depth of its mantle, the size of its core, without ever digging a hole. Section 3. Jupiter's bow shock. Mars whispers, Jupiter roars. On June 24, 2016, the Juno spacecraft crossed into Jupiter's magnetic field for the first time, and its WAVES instrument recorded the crossing. What it caught was the bow shock, the boundary where the solar wind, moving at over 1 million miles an hour, slams into Jupiter's magnetosphere and abruptly stops. It's a sonic boom made of plasma instead of air. And Jupiter's magnetic field is the largest structure in the solar system, after the Sun's own reach. If you could see it from Earth, it would look bigger than the full moon. Juno didn't fly up to it, it flew through a wall. Section 4. Saturn and Enceladus. A year later, at Saturn, Cassini caught something quieter and stranger. On September 2nd, 2017, 2 weeks before it burned itself up in Saturn's atmosphere on purpose, it recorded plasma waves traveling between Saturn and its moon Enceladus. That's a real connection. Enceladus is venting water ice from cracks at its south pole, and that material gets ionized and funneled along magnetic field lines into a current flowing between the moon and the planet. Cassini flew through that circuit and measured the electromagnetic signal, which was then converted into audio the same way a radio turns an invisible carrier wave into a voice. What you're hearing is a moon and a planet talking to each other in plasma. Section 5. Phobos. Back at Mars, its larger moon does something similar. Phobos is only about 22 kilometers across, small enough that its gravity is so weak a decent jump could put you into orbit. And it circles Mars 3 times a day. It rises in the west and sets in the east, twice every Martian night. Mars has no global magnetic field, so Phobos plows directly through the solar wind and through patches of magnetized crust below. Spacecraft passing nearby have measured the electromagnetic disturbances that stirs up. Turned into sound, it's a dry, hollow rasp. The noise of a small dead rock dragging through charged particles for the last few million years before Mars tears it apart. Section 6. The Singing Comet. In August 2014, the European Space Agency's Rosetta arrived at Comet 67P and detected something nobody had predicted. The comet's magnetic environment was oscillating, ticking, in a pattern regular enough that the team initially couldn't explain it. The frequency was around 40 to 50 millihertz, roughly one oscillation every 25 seconds, far too slow for human hearing. Scientists sped it up about 10,000 times, and what came out sounds like a swarm of insects clicking in the dark. The current explanation is neutral particles streaming off the comet becoming ionized and destabilizing the magnetic field around it. A 4-kilometer lump of ice humming to itself, 400 million kilometers from home. Section 7. The Vela Pulsar. Now leave the solar system entirely. A pulsar is the collapsed core of a dead massive star, a sphere about 20 kilometers wide holding more mass than the Sun, spinning and firing radiation beams from its magnetic poles like a lighthouse. The Vela Pulsar turns about 11 times every second. Every click you hear is one complete rotation of an object the size of a city and heavier than a star. Radio telescopes catch the beam each time it sweeps across Earth, and the pulse rate gets shifted into audible range. Some pulsars keep time more accurately than atomic clocks. This one has been ticking since before humans existed, and will keep ticking long after we don't. Section 8. The Helix Nebula. Some of these recordings aren't recordings at all. The Helix Nebula sits about 650 light-years away and stretches nearly 3 light-years across. The shed outer layers of a dying star, blown off and lit up by the white-hot core left behind. Nothing there is making a sound, so scientists sonified the image instead. A scan line sweeps across the picture from left to right, and the light itself becomes pitch. Red regions map to low tones, blue regions to high ones, following the same order as the electromagnetic spectrum. The result is a slow, aching rise as the scan crosses the blue interior. You're not hearing the nebula, you're hearing its light. Translated. Section 9. The Perseus Black Hole. But there's one place in the universe where sound is real. Space is a vacuum almost everywhere, except inside galaxy clusters, where hot gas is dense enough to carry a pressure wave. The Perseus cluster is full of it, and the supermassive black hole at its center is sending ripples outward through that gas. Chandra photographed the ripples decades ago. They're genuine sound waves. The problem is the pitch, about a B-flat 57 octaves below middle C, somewhere near 1,000,000 billion times lower than anything a human can hear. To make it audible, the frequency was raised by a factor in the quadrillions. It's the deepest note ever detected in the universe, and it's been playing continuously for roughly 2.5 billion years. Section 10. 2 black holes colliding, and then there's the one that isn't light, isn't plasma, isn't gas. On September 14th, 2015, the 2 LIGO detectors registered a signal lasting about 1/5 of a second. 2 black holes, roughly 30 solar masses each, spiraling into each other 1.3 billion light-years away. In the final moments, they were orbiting hundreds of times per second at more than half the speed of light. 3 suns worth of mass vanished, converted directly into gravitational waves, for that instant, radiating more power than all the light from every star in the observable universe combined. And what reached Earth was a ripple that stretched a 4-kilometer detector arm by less than the width of a proton. Convert it to audio, and it's a chirp, a rising swoop, and then nothing. That's it. Not a sound in the ordinary sense, but the actual shape of space-time ringing like a struck bell, 100 years after Einstein said it would. Every recording in this video is the same trick. Instruments catching something invisible and translating it into the one sense we trust most. The universe isn't silent. We were just never built to hear it. Which one got under your skin the most? Let me know in the comments, and subscribe for more.